Good afternoon, everybody. So this session is really for those of you who have some kind of an interest, whether you want to build an internal cloud, you want to build it for public services, you want to use it internally as your own optimization for IT. So I'm actually going to make it fairly pragmatic, and let me see if that works. Can you guys put up the slides? Okay, thanks. So what I'm going to do is I'm responsible for something which is called the Cloud Platform Group within Citrix, and we do a lot of projects of implementation and sizing and scoping of private clouds, hybrid clouds, public clouds, all of the flavors of cloud computing. And some of our customers are in the government, some of our customers are in the private sectors, some of our gamers, some are hosters. So there's all palette of deployments that we've done, and I decided actually to take just a couple of lessons learned to make it as pragmatic as possible if for those of you in the room who have some kind of a ongoing cloud compute project. So I'm going to try to flick through these fairly quickly to allow some questions and some discussion. We have a panel afterwards. But where did we learn from? Basically three categories of implementation. We learned from service providers. They were the first one to jump on this wagon of cloud computing. They saw what Amazon Web Services was doing, and then they all wanted to monetize somehow what they had in the data center. Right? So the Bell Canada, the British Telecom, the Singtels, the GoDaddy, so big hosting providers, big service providers, and then smaller or mid-sized managed service providers which are transforming their business from traditional managed services to become a cloud service provider. Then a second family of companies, completely different. They do not want to sell any virtual data center services. They actually want an infrastructure that is flexible to support their e-commerce, to commerce their life on the web, like Spotify, Zynga, which is a big social game producer of Farmville on Facebook. I think they run millions of gamers every day, and they want this elasticity in the data center. So they are actually customers of ours that push the boundaries very much of the technology in terms of true elasticity. And then I think since a year and a half, 2 years, you see a lot of interest from the enterprise and from the government. Enterprise, very much in test and dev environment, private cloud environment, application lifecycle management, and how do I actually offer internally as an IT department the same flexibility as my developers would get with Amazon Web Services, but do it within my environment, with my security, with my firewalls, with my approval chains, etc. And then on the government side, we see a lot of drive for data center consolidation and offer citizen cloud services based on an infrastructure that everyone can use and pay per use. So that's pretty much the type of spectrum from where the experience is coming from. In terms of what we deploy, there are a couple of building blocks. We usually start at the hypervisor layer, then we have an orchestration layer on top of that will make the whole storage network compute. So basically the data center infrastructure makes that very much an elastic abstraction of the actual hardware that is sitting there. That allows the on-demand compute, that demands the consumption metering. And then on top of that, usually with the service providers, or with companies that want to do chargeback, we need a portal somehow to onboard the customers. You want to build a catalog, you want to do real-time billing, and you want to offer real cloud services. Right? So these are the building blocks that actually make up that experience. There's a little bit of load balancing and cloud bridging technology to connect data centers with public clouds and move virtual machines from left to right and back and forth. And then there's right on the top there Windows or workplace as a service, which we see really an emerging trend within the enterprise, whereby desktops need to be provisioned on demand for different type of knowledge workers. So one of the first thing I would say is that openness matters in terms of these cloud projects. I think about 50% of the CIOs are looking into open source technology. Now, open source does not mean necessarily openness, and open source does not mean per se open source. But the fact is that you need to consider somehow a technology that will allow you to make a full abstraction of your data center infrastructure. You do not want to be fully hooked to a Cisco, to a VMware, to a HP, to a Microsoft, because you might want to go for some type of workloads with a very cheap commodity hardware. For other applications, you need an enterprise-grade environment. So you actually want to be able to build a cloud which will separate these two worlds as much as possible. And we see that that's definitely a strong requirement on the service provider side, because they don't know which data center they might take over from a customer. They don't know the hardware technology, where it's evolving, and you might want to separate the whole software layer from the hardware layer. You also want to consider what's happening in an open source community. The graphs are a little bit small, but let me explain. We are the green line. The blue line is another big project, which for those who are familiar with open source project is called OpenStack. We were one of the founders of that open source project. We're now part of the Apache Foundation. The fact that you build a cloud based on open source technology is a huge boost in terms of innovation, in terms of adoption, in terms of credibility with the developer environment. Because actually, if you look at whether it's for a public cloud or it's of a private cloud, the people that actually consume cloud computing, in first instance, they are developers. Right? The developers are the ones that demand actually the flexibility, the fast response like they get with Amazon Web Services. Right? So these are actually the community that in first instance push a lot of the demand. And so we went for Apache Cloud Stack a couple of months ago, and you see the adoption going through the roof. Suddenly you have 20,000 downloads a month, you have lots of people testing the environment. There's no need for a proof of concept, because our customers are just trying it out. Developers give the feedback to the IT operations department, and then they make a selection pretty much by themselves. If they want support, they'll come to a commercially supported version. But the fact that we went open source was a big eye-opener in terms of adoption and innovation. Also, the fact that your open source gives you a lot of openness to other innovative customers and innovative companies that you want to partner with. In cloud computing, you can see you got the installed names, the big brands that have been in IT for a long time. But actually, there's a lot of innovation. And for those who remember, a couple of months ago, VMware buying a company called Nicira with 0 live customers for $1.2 billion. I don't know, for those who remember that announcement, I'm sure there's a lot of VMware customers in this room. Actually, the integration between CloudStack, the orchestration platform from Citrix, and Nicira was done 2 months prior to the acquisition by a customer and ourselves. So the customer is an open source customer. They have tons of great developers. They want to do the virtualization of the network. They like Nicira. Nicira is a small startup. They build an integration, and then the product actually is supported within that version. That's the type of innovation that actually you also need to be aware of. In cloud computing, it's not just about the big names. In software-defined network is driven by small startups. Big data, object storage is driven by small companies that are being acquired by big companies. If you take the Microsoft stack, the whole cloud orchestration piece is a small company called Opalis that was bought. You take Cisco, they bought Tidal, they bought NewScale. These are tiny startups that were built, and then you put a big brand on it, and then you have an end-to-end solution. But the reality is that if the product is open source, if the product has a lot of open APIs, that ecosystem of innovation is actually building value-add services on top of that, and that makes the whole cloud proposition a lot more interesting. So our approach has been very much, you can buy everything or you can buy modules, and we feel that customers are actually liking that, because a lot of customers might have already a portal, a BSS, OSS portal if they're a service provider. They might not have the cloud orchestration piece. They might like another hypervisor than the Citrix hypervisor. They might want to do software as a service and buy some SaaS applications from Citrix. But the fact that you can decouple all of these things actually gives a choice for customers that like to build their whole cloud stack themselves based on the best practices that they think are in the market. Another lessons learned was the fact that cloud computing in Europe is quite different from cloud computing in the States. In Europe, it's very much a managed service cloud and a private cloud adoption. So we see very little interest in commodity cloud, and we don't really see any big player in Europe that is coming up and is trying to compete with a Rackspace, with a Savis, with an Amazon Web Services. It's a lot more about managing an environment which is with an SLA, which can be on-premise, which can be partly on-premise, partly at the data center of a managed service provider. We see that managed service providers are hesitant to provide a full self-service capability, which is kind of what cloud is all about, right? You want to make sure that it's automated, and you want to be able to delegate, just like with online banking, delegate as much as you can to your users. Now, the reality, I've been doing this now for a little longer than a year, and we've got about 50 customers that we've deployed in Europe. There's very little rush, I would say, from managed service provider to offer these self-service capability. I think there is a fear in the market that by providing too much of that self-service capability, you diminish the value add and the potential premium you can ask your customers for that. Well, actually, if you look at the users would love it. They love the fact that they can create their environment on demand. It takes minutes instead of weeks. They have the flexibility to put any application they want on that environment, and it is very intuitive from a user interface. So there's a little bit of I'd say a middle ground in Europe, and what we're starting to see is companies like DataPipe or SoftLayer, who are also here, I think I saw their stand out there, that are starting to offer on-demand private clouds. So you can go into a company like SoftLayer and you basically order your dedicated private cloud with all the flexibility. So it kind of matches the flexibility of a commodity cloud, but it gives you an SLA that will satisfy what the customers are used to from their managed service providers. Also, what we see is that there's a mix between multi-tenancy and physical isolation. So for some type of customers, you want to have a multi-tenant environment, and others want to have a dedicated physical environment, and others want to have a dedicated virtual environment. So we figured out that it's important to have a piece of technology that allows you to do different network configuration for isolations of applications and of customers. On one hand, the service provider like multi-tenancy, because multi-tenancy is actually more interesting financially and gives a lot of the flexibility, while customers tend to have the tendency to want to have private dedicated service. So there is a little bit of I'd say a transition that needs to happen in terms of cloud deployment, whereby you're able as a service provider to manage multiple environments between multi-tenant, logically separated and physically separated. But you want to have somehow a technology that enables that with a single management platform. I was saying self-service portals are high in demand, and there's lots of portals out in the market. So some are more IT catalogs, some are more cloud brokerage portals. Our experience is that portals are predominantly needed for customer onboarding, for user identification, for fraud control, for approval management, for offering a service offering and pricing actually what's happening in the data center. So if you take this schematic view on the right side, if that's your data center or data centers, you need a piece of technology that will make that an on-demand compute environment. But then on the other side, customers want just to buy a service. They don't want to buy a specific server of a specific brand with a specific set of memory. You actually want to have a number of service offerings against a price, against an SLA that can be billed at the end of a month. And ideally, you want to have as many of these cloud services published in a catalog. Now, if that catalog is going to be exposed as a self-service catalog to the end user or not, comes back to the point I made earlier, which is a lot of the clouds are managed clouds, whereby the service provider or the IT department within an enterprise will still keep a tight control and provision the services for their customers. So we had to create this portal. In the beginning, we didn't have any of that. We had just an orchestration layer, and then we had to build these portal one by one for service provider. We decided to make a product out of it that ultimately gives a white label portal to the service provider to kickstart their project. Most of the service providers or most of the IT departments wanting to build a private cloud do not have these capabilities yet. It's a very different type of billing, different type of onboarding. So the whole notion of having a cloud services catalog is new, and that's why we had to build that product that allows them to get started. I'll skip to these. The last piece is really important, and actually is that workloads will dictate the cloud infrastructure. Right? If you look at what are the use cases we encountered in this project, we always start to look at what is actually the workload that's going to go to the cloud. You know, is it a test and dev workload? Is it a web server? Is it a legacy application? Is it for high performance computing? And every workload will require actually an optimal architecture underneath that. In the past, it was you go to the cloud and then there's one architecture for the cloud, and if you're not in that architecture, you're actually not in cloud computing. Well, I think it's gone a little bit more sophisticated, whereby cloud workloads are divided into two categories, right? And whereby the traditional workload category is probably 80%, maybe 90% of the current workloads in enterprises. That means that these are legacy applications that require an enterprise-grade infrastructure, right? So the data center is designed with a typical vBlock, with a typical FlexPod. But on the other hand, on the right side, a lot of new applications, even from vendors like SAP, are being rewritten to be cloud-enabled. That means with distributed databases, with the ability to cope with failure on the hardware. And the advantage of the right side is that the intelligence is sitting in the application, and then your hardware costs can dramatically be reduced. Now, the fact is that not everything will move from the traditional workload to a cloud workload immediately. Right? If you take currently the infrastructure, the way to build the cloud, you have storage, network, compute. You put that into an availability zone with a network, and then you have multiple availability zones that make your cloud. Right? That's I would say the most basic construction building blocks of the cloud. But then how do you decide which infrastructure you're going to build for the next 5 years? And then how do you mix and match your traditional applications with the new cloud applications? And how can you actually build an infrastructure that will help you realize the benefit of cloud computing, which is scalability, which is flexibility, and which is also somewhere should be able to help you save some costs. Now, if you take the traditional workload, you all will know that, right? Because I'm pretty sure that all your data centers are built this way, right? It's typical storage area network. It might be a vBlock, a FlexPod. You have layer 2 VLANs. You have a very rich, feature-rich hypervisor, and then all this stuff is very resilient, right? It will practically never fail. It will have a very high level of SLA, but it's actually not going to give you much cost saving compared with a cloud architecture. If you take what we call an Amazon style cloud, you could see it's completely different, and that's actually how the big clouds in the world are built. Right? If you take a Google, if you take a Facebook, if you take a Zynga, if you take a Spotify, so all of these companies that come with large infrastructure need to support a large-scale deployment of applications and the flexibility, they work usually with commodity hardware, they have elastic load balancing, they have an object store, and the whole design is completely different. They're virtualizing the network. So the question is, if everybody is talking about going into cloud and being able to serve the customers of tomorrow, really, you have to think about what type of availability zones you will build today and for the next 2 to 3 years, because you might actually not need an enterprise-grade architecture to support the new cloud-enabled workloads. And the cloud-enabled workloads today might be only 10%, but in 3 years, they might be 30%, and they'll go to 50%. So the question is, if you are an enterprise who supports your developers in-house, if you are a service provider who wants to offer cloud services, are you able to scale at an economical rate for the demand that is coming for these new workloads? And that's really something we discovered pretty recently, because in our discussions, initially we had customers that wanted or an enterprise environment, or they were web companies and they built their infrastructure very differently. We figured out that actually you need something that can manage both. And if you are a service provider, you're probably going to have your first availability zones built under a VMware infrastructure, typically enterprise grade, because you want to onboard your existing customers. But on the other hand, you might have or your own applications that you're developing and testing, or you want to onboard some of these gaming. I hear there's a lot of gaming companies that are interested in Luxembourg. Well, guess what? The gaming companies, they probably don't need a vCenter type of architecture, but they'll be probably more on the cloud-enabled infrastructure and at price points which is actually a lot lower than the enterprise side. So a lot of our discussions are about managing both type of architecture and both type of workloads, but being able to manage that with a single cloud management layer, so that you're not tied into one architecture or the other, but you can create availability zones that will support different types of use cases. Okay, so key takeaways is probably the biggest one is, what workloads will you bring to the cloud and what's the architecture that you will build it upon? Do you have a technology that can support both, right? Or are you tied into the traditional workloads and that's what you're going to build your cloud upon? And then choose a platform that can probably address both of that. And that's it. I think we are right on time. Thanks for your attention.